over 10-1.
The kids and math teachers will
Right? This is a point. This is a line. This is a ray. Okay. What number?
Number 33 was the first one I ran into where the x plus 10 was in parentheses. And then was the degree.
Yeah, so it's saying x plus 10 is the measure of the angle. So if you want to find, it's asking you on 7 through 34 to find the measure of the complement of each angle. Okay. So the complement tells you x plus y is 90 degrees, right? If I have two angles and they're complementary, they add up to 90. So here, this is going to be x plus 10 plus some y equals 90. You're going to have, your answer is going to have an x in it because that's the variable. So here it's saying if x is 0, the angle is 10 degrees. So my complementary angle is going to be 80 degrees. So if I go ahead and solve for y would equal, see, 90 minus x minus 10, which would be 80 minus x. So if I tell you what x is, you can tell me what y is, and y is the complement of that, where x and y are going to add up to 90. So this is kind of the approach to algebra. You know, instead of saying we know what the angle is, let's call it a variable. So if I have angle x, you want to know what's the complement to x. That's going to be x minus 90, right? Because whatever x is, I take 90 minus that, and I get the complement. Here is x plus 10, so the complement is 80 minus x. If x is 0, this angle is 10, and this one's 80. If x is 1, this angle is 11, and this angle is 79. If x is 2, so forth. Okay. So you're finding a formula for the complement.
So on 41, did you do the same thing with 180?
Yeah, so 41 is the exact same approach, but it's with 180. It's leading you up to word problems. Okay. Saying there's some angle that's 20 degrees greater than another angle. It's setting you up for that approach to a word problem. So this is saying take the angle and add 20 degrees, find its supplement. So here I'd say x plus 20 degrees plus some y degrees is 180 degrees. I would solve for y, because y is my supplementary angle in terms of x. And then if you have an x value, you can find angle 1 and angle 2. And you'll have that formula for any x value.
Number 43.
43.
Yeah. You look at that one, x plus 5, and it's complementary, so that means 90.
So it means when you add these two angles together, you get 90. So then you solve for x, plug x back into A and B, and you get your angles. So setting this up, this would be x plus 5 plus 2x minus 15 equals 90. And this is where the algebra comes in. It's all linear. So you solve for x. We have 3x equals 80. No, sorry. What would this be? Minus 10, so this would be plus 10. So this would be 3x equals 100. X would end up being
Just left it as 100 over 3.
okay, that's fine.
I didn't see how they were getting there, but now I see. I think I overlooked in the directions where it said supplementary,
Complementary. And you're saying, what am I doing?
Yeah, and seeing that now, I go, oh, okay.
So you're adding the two angles together to either 90 or 180,
Okay.
and then solving for the missing value. And the same thing on 47 through 50, except they're going to equal 180.
Okay. That makes a lot of sense now.
If you plug x back into A, you know the measure of angle A. If you plug it back into B, you get the measure of angle B. And if you add those together, you should get 90.
Okay.
Any other questions on 10.1? So we spent a lot of times on just kind of the basic definition of point, a line, a plane. And we went into parallel lines and transversals. We talked about vertical angles. We talked about alternating interior, alternating exterior, and corresponding angles. So that allows you to solve some of the problems later on in 10.1. So last time we said we're going to continue on with triangles, and eventually we're going to kind of merge some of these things and have parallel lines and triangles and a lot of things together. So the learning objectives for 10.2 is to identify types of triangles. So these are just kind of definitions. You're going to name them, you're going to classify them. Within a given triangle, find one missing angle in the triangle. So if I give you two of the other angles, you can find missing angles. Use the Pythagorean theorem to find the side lengths. This only works with right triangles. So you have to know that you're given a right triangle. You can't do it with any other types of triangles. And then we're going to use similar triangles to find length. So I'm sure you guys have maybe done this in middle school where you have to like measure height of a building, and you know the height of 1 meter stick, and you go outside and you measure the shadow of the meter stick, you measure the shadow of the building, and you use ratios. Did anyone ever do that? Middle school, high school? Some of you, yes, some of you not so much. But that's kind of where we're going to end up using similar triangles to find the missing side lengths given two triangles. So we get into more of the definitions, and in geometry, we have closed figures, and a figure is said to be closed when you start at one point, trace the entire figure, and finish at the same point you started without lifting your pen or pencil off the paper. Triangle is a closed geometric figure that has three sides and three angles. The three sides of a triangle are line segments, and the points where the sides intersect are called vertices. One way we can name a triangle is according to its vertices, using the symbol triangle in front of it. So if I have triangle ABC, in this case, order doesn't matter. Like we said, sometimes with angles, if I said ABC, I'd be talking about this angle here. If I said CBA, I could be talking about either the exterior angle or the interior angle. In triangles, the order doesn't matter of what you name it, but the symbol is important, the symbol on front. Because if I just have ABC, I don't know if you're talking about the triangle ABC or the angle ABC. So the symbol out in front is important. A few types of triangles we're going to classify. Isosceles triangles. Isosceles are when you have two equal sides. Equilateral triangles are when you have three equal sides. A scalene triangle has no equal sides. So all sides are different lengths. So isosceles, equilateral, and scalene. And then we can classify triangles by their angles instead of their side lengths. So isosceles, equilateral, and scalene classify triangles based on their length of their sides. We can classify them by their angles. So this could be an equilateral triangle. It could be a scalene triangle. It could also be an acute triangle. If all the angles are less than 90 degrees, it could be acute. If all the angles were 60 degrees, it would be an equilateral triangle, but it would also be an acute triangle. So sometimes these names can overlap. Right triangle is when you have one right angle. This could be an equilateral, or couldn't be an equilateral. It could be a scalene or an isosceles triangle, but it also could be a right triangle. A obtuse triangle is when you have one angle larger than 90 degrees. All right, you guys have done this before. You've heard these terms. We really don't do much with it except classify it, and that comes up later on when we talk about like the Pythagorean theorem. We can't apply it on an or on a equilateral triangle. We have to have a right triangle. Identify the types of triangles. So what would you identify as A? Obtuse, right? We know nothing about the side length. Could or could not be equal as far as, you know, this side could be equal to this side, but we don't know that because it's not marked. So the only thing we have to go off of is one of the angles is larger than 90 degrees. What about B?
Equilateral.
We'd be able to classify it as acute and equilateral, right? All sides are the same length. Corresponding to that, all angles have to be the same measurement. And we'll get there, but this could be classified as equilateral and acute. And then C, right. Any questions on that? The sum of the angles in the triangle is 180 degrees. A fun way to kind of show this to your class is have them make triangles. Everyone make their own triangle, and then have them tear off the corners of the triangle and then lay them down and see that it makes a straight edge. And we know the angle of a straight line is 180 degrees. So if I snip off the corners of any triangle and I lay them out, it's always 180 degrees. So it's just kind of a fun visual representation. I know some of you guys want to be teachers. And that's just kind of a fun way to show that. Instead of just say memorize 180 and don't think about it. Think about it's going to add up to a straight line, which is 180 degrees. Find the missing measurement. So if I have 40 degrees on angle A and 40 degrees on angle B, what is angle C? 100, right? Eventually we'll get into more like, oh, this is x plus 3, and this is 2x minus 4, and this is, 5x. Find the missing angle measurement. So eventually we'll get there where it's more at a little higher level. But the concept's the same. I add those 3 angle measurements together and set it equal to 180. Pythagorean theorem is used to find a missing side of a right triangle. It only works in a right triangle. And we can set it up to be a squared plus b squared is c squared. We can use this formula to find a, b, or c. And we'll do some examples of that. In addition, if the sides of any triangle satisfies this relationship, you can confirm it's a right triangle. So the if and only if goes both ways. If it's a right triangle, you can apply this theorem. If this theorem works in any triangle, then it's a right triangle. Here's an example of using the Pythagorean theorem. So we're given a right triangle, and we're given the lengths of the 2 legs, and we want to find the hypotenuse, side C. So I set this up 24 inches squared plus 10 inches squared equals C inches squared. That's my formula. So if I plug the left-hand side in my calculator, I get 676. I set that equal to C squared. So to solve for C, I take the square root of both sides. And then distance is always positive. So some of you say, is it plus or minus? But you can never have a negative distance. So you always take the positive version of the square root. So this is 26 inches. They might not all come out very nicely, but I think most of them in the book, it shows it to be nice. Any questions on that? You guys have done Pythagorean theorem before? Some of you are like, yes, we've seen that before. Okay. Here's an example of an application problem to build a frame for a roof. of a shed, the carpenter must cut a 2x4 to fit the diagonal of the length of the horizontal beam. It's 12 feet, and the height is 3 feet. So we want to find the length of the diagonal. So you're looking for this length here. If you're going to build a roof, you want your pitch to be 3 feet and your distance to be 12 feet. We want to find the length of the diagonal. This is a Pythagorean theorem problem. One thing students struggle with here is visualizing the picture. A lot of times it'll be given to you. Here's the setup. Here's the tree. You want to find the height of the building. Here's the 2 triangles. But what's really difficult is when they just give you the words and expect you to draw the picture. So you have to get a little more comfortable with that sometimes. So this one's not going to come out perfect. This is going to be 3 squared plus 6 squared equals question mark squared. Right? So we have 9 plus 36 is question mark squared. What is that? Question mark squared equals 45. What's the square root of 45?
6.7.
So 6.7 feet, which is also, I'll go ahead and get that. 3, the square root of 3. And this is a special triangle in trig. It's a 1, 2, square root of 3 triangle. It's a 30, 60, 90 degree triangle. If that's just Greek to you, that's okay. We will get there eventually doing basic triangles, and there's really kind of 3 basic triangles in trig where you know the ratio. And any triangle that has a 30, 60, 90 degree angle measurement will always have the ratio of 1, 2, square root of 3. So if this side was 3, this side 6, this one's always going to be this side times the square root of 3. So if this was 1, this would be 2, this would be square root of 3. If this was 6, this would be 12, this would be 6 the square root of 3.
3 square root of 5.
Huh?
3 square root of 5.
3 square root of 5? 6? What's 45? What's square root of 45? 5 times 6? 5 times 6? No. 25. 9? 5 times 9. 5 times 9?
Mm-hmm.
1, 2, this is the square. Oh, it's 1. That's right. This is not a 30, 60, 90 degree triangle. It'd be 1, 2, square root of 3. 30, 60, 90 is 1, 2, square root of 3. So this is not quite a 30, 60, 90. We know it's a 90 degree triangle. We know it's a right triangle. So one side's 90. If this was 30 degrees and this was 60 degrees, oops, switched them. This was 30 and this was 60, we would know the ratio was 1, 2, square root of 3. So eventually that's what we're leading to. But at this point, it's just applying Pythagorean theorem. So you guys are, some of you are looking at me like, why did I show up to class today? I know all this. Eventually we're going to get to things that you don't know. So just be aware of that as the next couple of weeks go by. And that's always true. So the first couple of sections and all these are just like, yes, I know what a point is. I know what an angle is. I know, and we're going to get to like area, and you might know those and think, what am I doing here? And I'm just going to skip. And then we'll do something you don't know, and then you'll be lost there. So just kind of stay with me. Similar triangles. So similar triangles use ratios. The fact that the similar triangle is off by a factor or a scaling multiple. If I take a triangle and I stretch each side with the same number, they're going to be similar. So these are called similar triangles. So if I take this and multiply it by 3, I get 30. If I take this side, multiply it by 3, I get 18. If I take this side, multiply it by 3, I get 12. So we're going to use the fact that we can write similar triangles and then find the missing side of one of the triangles. If we know they're similar, and I ask you to find this side, you can find the factor they have in common or the ratio. 10 is to 30, and 6 is to what, and then solve for the what. In similar triangles, the angle measurements are congruent. They're the same angle. This angle is equivalent to this angle. That's one thing triangles preserve with similarity is the angles are going to be congruent. They're going to equal up to each other. So it turns out since the angle measurements are equal, they're called corresponding angles. So B corresponds to B prime, A corresponds to A prime, C corresponds to C prime. Yeah, so when they're equal, their corresponding angles have equal measurement. And when we know two triangles are similar, we can take the ratio of their similar sides and set them equal to each other. So the side length of AB divided by the side length of A naught B naught is going to be the same ratio as the side length of BC divided by the side length of B naught C naught. So let's look at an application of this. Here, 10 over 30 is the same as 4 over 12, is the same as 6 over 18, is the same as 1 over 3. It doesn't matter what you put on top and what you put on bottom as long as you're consistent through your equals. So here we put 4, 10, 4, 6. These are all of our first triangle. Then we have 30, 12, 18. Those are all the second triangle. You could say 30 divided by 10, 12 over 4, 18 over 6, and get 3. The difference is saying is I'm taking this triangle, multiplying by 1/3 to get this triangle. Or I'm taking this triangle, multiplying by 3 and getting this triangle, right? And I'm going to show you the different setups when you go to solve for the missing piece. So these two triangles are similar. So it's given they're similar. You don't have to prove that. Find the length of BC. So what would be one ratio I could set up? There's many of them.
I did 8 over 6.
8 over 6 equals
12 over
question mark.
Yeah.
How would I solve for question mark?
6 times 12.
Yeah. So you guys have heard of the term cross multiply and divide. So this would be 6 times 12 divided by 8 would give you the question mark. So what's 6 times 12 divided by 8?
9.
Is it 9? Let's see what we get. Right here, it's the same one the lecture did. We got 9. There are multiple ways to do this though. Go back here. What would be another way I could set up the ratio?
So 6 is
Go ahead.
You can do 6 over 8, and that goes into 3/4, and then 12 times 3/4.
So you could go 6 is to 8 equals question mark. Oops. Question mark over 12.
No, 6 to 8, that simplifies
Mhm.
to 4.
Okay, and you're gonna
And then
say.
you're gonna times 3/4 by 12.
So you're saying, so that's a good way to do it too. It's a little different. What you're saying is, you know, the multiplying factor is 6 over 8. To get from this triangle to this triangle, I take this number and take it times 3/4, and I get this number. So I'm going to take what times 3/4 is going to give me 12. There's many, many different ways to look at this, and some students get frustrated because they try to force one way. What you want to do is you want to set up your ratio. I could also say 8 divided by 6 is 4/3, right? So 12 times 4/3 is going to give me question mark. There's one last, you could go 6 over 8 equals question mark over 12. You're going to do the exact same math here. 6 times 12 divided by 8, because you cross multiply and divide. The ones that are across each other, you multiply, you divide, you get question mark. And you get the same answer as 9 inches. So you can multiply both sides and then end up dividing by 8 to get 9. Another application is using the height of something that you know to find the height of something you don't know. So this works in this case. You assume it to be right triangle, but you're not applying necessarily the Pythagorean theorem here. The tree casts a shadow of 12 feet. You can measure a shadow, right? But it's really hard to measure a tree. So if I have a tape measure, I can go out there and measure the tree shadow. If I stand on the same time of day next to the tree, I can measure my shadow and I can know my height. So if I'm 5 foot 10 inches and I have a 5 foot shadow, I want to know the height of the tree knowing it has a 12 foot shadow. So this is a setup of similar triangles. 99 times out of 100, it seems if I give the picture, students have no problem. But if I take away the picture, students struggle. So you have to have some connection to be able to say, okay, this is the person's height. It's given. This is the height of their shadow. And then here's some tree. I don't know its height, but I know its shadow. And I want to find the height of the tree. I'm going to name that X. You got to be a little careful here. Since everything else is in feet, you need to convert this into feet, or you need to convert everything into inches. You need to use the same unit of measurement, multiplying and dividing, because feet times inches doesn't make sense. So this is a common thing in the next couple of sections. We're going to talk about area and volume and surface area. If I give you, 1 foot and then I give you 13 inches, and you say, okay, 1 foot by 13 inches, I have an area of 13, doesn't make sense with your unit. So your units are going to come important here. So the first thing you need to do is calculate how many feet this is, or calculate how many inches everything is. Your ratio is going to be the same. If you take everything in inches, your book does it in feet and they deal with fractions. A lot of people try to avoid fractions. So I could make everything into inches and get the same answer, because your answer is going to be in inches, and then you can convert it to feet, or you're going to get something similar. So if I went to inches, right, there's 12 inches in a foot. So 12 times 5 plus 10. So this would be 70. This would be 60. This would be 144. And I could take the ratio is 70 over x equals 60 over 144. Take 70 times 144 divided by 60. What do we get?
168.
168 inches. If we divide that by 12, we get 14 feet. Right? If you have a calculator, it shouldn't be difficult to necessarily see 5 feet 10 inches is 5, the mixed fraction 5 10 over 12. But you could convert everything to inches, calculate inches. Your answer can be in inches, and that's fine, unless it says find the answer in feet. So let's look at some of the homework problems from this section. And sign into your book. So yeah, pass around the sign-in sheet. Thank you. So in 10-2, you're assigned 9 through 35 odd. So 10-2. All right. 9 through 35 odd. So the first couple ones are classifying the triangle, and sometimes you can classify it as based on the angle measurement. Sometimes you can classify it based on the side measurement, and sometimes you can classify it as two types there. And then later on you do find the missing side length C. And it turns out you have to be a little careful. If in this setup, they give you A, B, and C, but it's not always listed as A, B, and C. A, B, C. It doesn't matter what you call A or B, since they're side lengths and they're on the left side of the equal sign. So here they give you A, B, A, B, A, B, A, B. But 27 and 28, they give you B and C. So you have to actually find for A. So if A squared plus B squared is C squared, then A squared equals C squared minus B squared. So A equals the square root of C squared minus B squared. And then you have some fun different, you have to calculate these to be both B and C or both in yards. Or you have to calculate these both in inches and both in feet. Right? You can't add feet and yards together. It doesn't make sense. If I say you have 3 feet and 5 yards, you don't have 8 feet yards. You know, you have to be careful with that. So 12 inches in a foot, there's 3 feet in a yard. So you need to know those conversion factors to either take it all to feet or all to yards. If you go to feet, then your answer is going to be in feet. If you go to yards, your answer is going to go to yards. And I'm not sure in the back of the book if it gives you the answer in both or just in one. So then you can convert.
Do you prefer like with inches or feet? Do you like prefer feet or?
I would tell you what to put your answer in. Sometimes if your answer is really large, you know, like 144 inches, it makes more sense to put it in feet. But if it's small, if it's 0.3782 feet, it makes it more sense to put it in inches.
They only give you.
They give you one?
29. They do it in feet.
Probably.
31 they do it. Oh, 31's not on there.
Yeah, it's 30.
Yeah,
So
it's just.
it's probably in feet as well on 30. But you can kind of, if it's in feet, inches, yards, centimeters, miles, feet, that just tells you what your units are. You know, if I give you the distance from here to the door, eventually we'll get to like area. If I give you the distance of this wall and that wall and calculate area, you have to have the same units. So we'll do some of the conversion units when we get to area. We'll do area of the triangle as well. Then you get into some similarities. So you know these two triangles are similar and you want to find the missing unit. These are all pretty straightforward. Their orientation is the same. so you can kind of see the corresponding sides. But be careful if the orientation was flipped. See if they give an example of one where the orientation, here. These two are really, you have to be tricky with them because this 34 actually corresponds to the X, right? The side opposite of the 90 degrees corresponds to the side opposite of the 90 degrees in this triangle, right? If I was to pick up this triangle and write it like this, this would be, if I put this to be, this would be D, right? D to E is the same as C, because these are vertical angles, so they're congruent, is the same to C to A. So D, E, and then this would be the vertex here, B. So D to B is 12, and they're giving you E to B as X. It's much easier to see the similarity here when it's set up like this, right? Because these are corresponding. I just pick this up and put it right on top of here, and I can see this side corresponds to this side. This side corresponds to this side. This side corresponds to this side. It's harder to see it this way, so you have to be very careful that corresponding parts correspond correctly. So a lot of times the angles will give you links to that. So if this is 90 degrees, across from the angle of 90 degrees is 34, is going to be 34 over X. And then I would use 24, because that corresponds to 12. 10 meters here doesn't mean anything. I could also, yeah, this 10 doesn't necessarily mean anything. If I do the ratio there, it's going to find the length of DE. These are right triangles, so I could use Pythagorean theorem. But I don't want to find this measurement, then use Pythagorean theorem to find X. So you have to be very careful. Corresponding parts correspond correctly. So here, this angle is equal to this angle, right? So that means this side is similar to this side. Question? It started passing around. I don't know where it ended. So do you guys see how sometimes it can look really tricky of what corresponds with what? So we have vertical angles are congruent. So we know 1.8 over X. Then I have to find, is it 3 kilometers, 2 kilometers, and 10 kilometers? How does that relate? Right? So we know they're similar. So it turns out if I invert it, do I have to invert it? If I come over here and try to draw it the same way, I know this is point C. If I call this point A, is this A or B? CA is 3. We know this is 3.
B would be on the bottom. Yeah.
B. So AB is 1.8. CB is 2. So if I look at this triangle and this triangle, it's a lot easier to see. I'm going to do 10 over 3 equals 8 over 1.x. X over 1.8. Or I could do 1.8 over x equals 3 over 10. But it might be harder to see. Am I using 2 or 3 here? $38, you have to be a little careful. This side length in this triangle is actually 11 plus x. So the ratio could be 7/14 is the same as 11/11 plus x. Right? The smaller triangle's base is 7, the larger triangle's base is 14. So if this was 11, the ratio would be 11/11 plus x. So then solve for x. Same thing on 40. You don't do 40, but this would be 6 plus x. So x, if you did,
6/6 plus x.
it would just be 6 plus x. Would be the height of this, the larger triangle here, the height is 6 plus x. The height of the smaller triangle is 6. Right? 10/12 would be the same as 6/6 plus x. And then you still cross multiply and divide. Let's look at this for a minute. If I cross multiply this, I end up with 7 times 11 plus x equals 11 times 14. You have to be careful that you distribute here. 77 plus 7x equals whatever, 14, 154. 154. And then solve for the missing x value.
So then you just take both sides minus 77 and then divide by 7.
Yeah.
Right?
Mhm.
I don't think that's matching with what I'm looking at in the book. I don't know if I'm looking at something wrong. Section 10-2,
Does your guys' book look different?
yeah. Line number 38
Mm-hmm.
is like the flippy one with 1.8 kilometers, 10 kilometers. Maybe the numbers are just off.
This book
Yeah, it was
is
39. It was number 39.
number
39
39.
and 40.
So the numbers are off, okay.
Is it just, it might be, I might have pulled up the different version.
Okay.
Yeah.
But the problems are going to be very, very, very similar, not exact. And then again, a lot of these don't have pictures. So you have to read and be able to interpret, you know. The television screen, the length of the diagonal from one corner to another is 52 inches. Widescreen TV is 24.8 inches high. Widescreen, the TV is 24.5 inches high. How wide is it? So if you have a TV here and you know the diagonal
Is 52 inches.
is 52, how wide is it? Oh, high. You know it is 24.5 inches high, so 24.5. You're looking for how wide it is. So you're looking, and this is like the A setup. You're looking for A squared. You're looking for A. A squared plus B squared is C squared. But you have to be able to draw that picture.
I hate word problems.
And this is the thing that I've seen before in this class. If I give you a picture, no problem. Do it all day. If I give you the words, you can't connect that to a picture. So that takes some practice, and you'll be tested on that. Being
So just draw
able,
me a picture of a TV.
you draw
and-
me a picture of a TV.
Throw the numbers in for me, and then I can do it.
Swimming pool, 18 by 36. So a vacuum hose has to be long enough to reach one corner diagonally opposite. What's the length of the shortest hose that will work? Can you guys visualize that? The swimming pool, what's the diagonal of the swimming pool? So you know it's,
I don't do word
you know it's 18 by 36.
Uh-huh.
Well, in this case, 36 by 18, the way I drew it. It doesn't matter. You're looking for this missing value. So it's rectangular, so you know the angle measurement's 90 degrees, so you know it's a right triangle, so you can use Pythagorean theorem.
So you just take a squared plus b squared equals.
X squared. Yeah, so you would do this as x
36.
equals 36 squared plus 18 squared and the square root of that. So don't be intimidated by the word problems. A lot of times it's just draw a picture and then from the picture answer the question.
Give me that, I can do that. That one's easy.
There's another tree one. Sometimes they give you pictures, usually when it's a little more complicated and you might be a little disconnected from the type of thing they're talking about. You know, swimming pool, if you've never seen a swimming pool, it's kind of hard to imagine that. Here, sometimes it can get a little long-winded, so a lot of times they give you a picture. A local mall, here's the height of the tree. The height of a watchtower, I don't know, find the height of a tower. Yeah, you have to find out how long this hair is.
It's long.
Eventually we'll get into some like this, where we'll talk about how are 1 and 3 related. If 1, 2, and 3 is 90 degrees, and 4, 2, and 5 are 180 degrees, right? It turns out we have parallel lines here. We have a transversal, alternating interior angles.
Oh, is that where you
Are going to be congruent.
Is that where it's?
So 1 and 4 have to equal each other because they're alternating interior for that transversal. And 3 and 5 have to equal each other. The reason why is because 2 plus 4 plus 5 is 180, and 1 plus 2 plus 3 is 180. So 1 has to equal 5, and 3 has to equal 4.
Yeah.
And eventually, I'll give you pictures like this and say, I'll give you one angle measurement, and you have to find some of the missing angle measurements. And they might even get a little bit more complicated. You know, something like that. You have 2 triangles. You have angle measurements. If this was 90 degrees, then you would know these 2 angles add up to 90. And eventually, it's just kind of parsing through what's going on. Yeah. So here, why would 1, 2, and 3, what is 1, 2, and 3? 1, 2, and 3 is a straight angle with 180 degrees. 2, 4, and 5 is the sum of triangles, so that's 180 degrees. And then if you take out 2, you know 1 plus 3 and 4 plus 5 have to equal each other. And then you can parse through some of that. So go through some of those homework problems. On Wednesday, we'll talk about polygons and perimeters. So again, we'll talk about, now you have that swimming pool and you want to build a fence around it so your kids don't fall in it. So how much fence do you need? You guys have all done perimeter, and right? And yeah. I mean, really, this section is, and sometimes it's nice to do at the end because it's a little less, yeah, just to kind of go into it. It does get a little bit more involved. The level of problems, the algebra gets thrown in there. Like, you know, the fence costs X amount. You only have X amount to spend on the fence. Your neighbor's
So you're not making a fence.
Your neighbor's going to half the cost to the left.
On the ground.
The other neighbor will give you $50 for the fence, so you have to make sure you can find the area and perimeter. So you need to have this fence based on how much your neighbors will pay you.
See, I like my solution. You just don't build a fence.
You just
My
don't.
neighbor's gonna
Tell
put
your
more than
kids,
$50
sorry,
towards
your
it.
SOL, no pool for you.
I have a question.
Okay.
Yeah, yes. About 21 on the map. I mean, on the homework.
Number 21.
Yeah.
Okay, let me